bit of time kind of going through some of these. I'll give you guys a little bit of chance to kind of work through them. We'll talk about them. These are the types of problems that you're going to see on the quiz tomorrow. They're all going to be kind of mixed up. Some are surface area, some are volume. You got some that you're like working backwards to find the radius or the height or whatever it is that I'm trying to find. And then you will also have some of those where you have to find like the surface area or volume based on another surface area or volume, where you have to set up the proportion type problems. Okay, some of these are going to be real straightforward. Some are going to be a little bit harder than others. So I'm going to give you a little bit of time on each one. See what you think you would do. This one, we're finding the volume. Probably more volume than surface area. There aren't a lot of surface area questions. Okay. The first question you should always ask yourself, when I have a volume question especially, we got to figure out which formula we're going to use, right? But even when I decide what formula I'm going to use, the first question I need to ask myself is what? What's different about each prism that we might see? The base, right? What is the base? So the base is what I have two of. There was one on the homework where it was like a trapezoidal base, okay? And but it was like looking at you this way on the big ideas. So the base doesn't always have to be the bottom side, okay? And I don't necessarily, on this one, you could think of the base as being a lot of things. Obviously, most of the time we think of the base as being the bottom, but it doesn't necessarily have to be. In this case, we just have a rectangular prism. So my base, I kind of like to outline the base. It doesn't just come right out and tell me it's a rectangle, but I know it's a rectangle because I got 4 right angles. I got 2 dimensions that are not the same, so it's not a square, it's a rectangle. And the one thing that we've been doing over and over again, whenever we have something like this, big B represents the area of the base, right? And it tells you that there in your formula. Big B is the area of the base, but that's why we got to decide what kind of figure we have. In this case, it's a rectangle, okay? And to find the area of a rectangle, it's just 8 times 17 times 12. 12 would be the height of that prism, okay? So that one's pretty straightforward. Length times width times height. Probably one that you saw way back when you did 3-dimensionals, probably in middle school. Length times width times height is a pretty basic figure, pretty basic prism. What is the number for that? What do we get? $4,032. Oh, 1,000. Okay, sorry. 32. Okay, and then our labels. Here's what I'm going to do on the quiz tomorrow. A couple people have asked me about labels. If you label every single problem correctly on the quiz, I'll give you an extra credit point. Okay, so you got to label it with the right units, inches, feet, centimeters. That should be pretty easy because it's whatever units in the problem. If it's volume, it's always cubed. If it's inches, it's always squared. Okay, so if you can do every single one of them right, then that should be a free extra credit point for you. With some people look at number 1 and say, well, there's no picture on our formula sheet that looks like this, right? There is no rectangular prism, okay? The one on the top left is just for all prisms, okay? And the area that is darkened in is your big B, and it has a big B pointing to it. Your base is going to change. The reason we didn't put every single figure on there is because you can have a rectangular base, you could have a square, you could have a triangle. All of your bases could change, right? So we can't put all those figures on there. Just know that this is the same as, okay, once again, finding the volume. The biggest question we always ask ourselves is, what is big B? This is another prism, okay? And I know the figures aren't labeled. And so, like, if I look at number one, here's what some people struggle with. This, except that the base is a triangle. And so you could color it in if you want to, right? That is the base that I'm looking at. The two bases are the same size. So if this one is 9 by 12, this one down here is 9 by 12. If this one down here has a 90-degree angle in the corner, this one up here has a 90-degree angle in the corner, okay? Because the bases are the same, all their dimensions, all their parts, all their pieces are the same as well, okay? Sometimes people struggle with that because down here they have a 90, this one doesn't. Here the sides are measured, this one doesn't. You can measure or you can label both top and bottom if you want to. Okay, but what kind of base do I have here? Triangle, okay? So that's why I always write next to big B what it is, okay? Because the formula is going to change. Last time it was length times width because there was a rectangle. Now we have a triangle. What's the formula for the area of a triangle? That's one that's not on your formula sheet. How do I find the area of a triangle? Yep, base times height divided by 2. And then we'll multiply that by the height of the prism. Okay. Now, the one thing that can be a little bit confusing here, this is the height of the triangle, this is the height of the prism, okay? Those are two different heights. So that one is the height, and if you wanted to, you could say this is the height of the triangle, if it made more sense to you. This here is the height of the whole thing, okay? So there's two different H's, and they're different, okay? It can be a little bit confusing, but they're both considered to be heights, just different types of heights. So we'll do 12 times 9 divided by 2 times the height of the prism. And I'm going to tell you right now, the most common mistake that people will make here is they'll forget to divide by 2, okay? Because it's a triangle. A lot of people will just take 12 times 9 times 16. Because that's what we did on the first problem, right? We just took length times width times height, but this is not a rectangle. So that's why we're going over this. People forget to divide by 2 here. And they say, well, that's an easy mistake. It is an easy mistake, but that's going to make your volume half as much, and it changes your answer quite a bit. Okay, so we should be able to just type that in. What do we get for that one? 864. Okay, and then it's meters and it's volume again, so it's meters cubed. Okay, this one should be pretty easy to recognize. This one is a cylinder. It's the top right problem, or the top right formula, and we are finding the volume. This one should be pretty straightforward. I'll give you a few seconds to try to plug this one in. trying to find the volume. Okay, the radius is 11, so we just take 11, plug it in for R. My height is 26. Okay, and I'm pretty sure that on the quiz tomorrow, I think every problem we're just going to ask you to round to the nearest hundredth. So you don't have to worry about leaving it in terms of pi like we've done sometimes. We're just going to multiply this all together in our calculator and then round. Be careful with your rounding. Pi times 11 squared times 26. Okay, you're going to get some fairly large numbers sometimes. This one, and it's volume again, so we just take whatever unit it is and put cubed on it. Volume's always cubed, yards cubed in this case. Okay, everybody good there? The only thing I would say there is be careful, like if they give me a line that goes all the way across, then they might label this like 22. So then I have to divide by 2 to get to the radius, okay, which would be 11. So to pay attention if the line's all the way across or if it's only halfway across. If it's halfway across, it's the radius and we're ready to go. We got what we need. Okay, try this one. I'll give you a little bit of time on this one. I always like to either outline the base or shade it in like it is on the formula sheet. Okay, what formula am I using for this one? One-third BH, right? 1/3 big B times H. So we definitely want the 1/3 in here. We know we're going to use the 1/3 when it comes up to a point. We have a pyramid here, okay? Same would be for a cone. But this has a base that's a polygon. What kind of base do I have here? It's a square, okay? All the sides are the same. So right above big B, I'm going to label this with a square. We don't have to label big B when we have a circle because a circle is always a circle, right? When it's a polygon, we want to label what type of polygon do we have. As long as it's the perpendicular height, and it does have a right angle coming from the top of the pyramid down to the middle of the base. So my height here is simply just 3. Okay. So this is really just plug and chug again. Okay. Plug in area of the base times 3. The most common mistake here is people will forget to divide by 3 here. That's why we got to make sure that we use the 1/3 BH, not just BH. Once again, we're talking about volume, so this would be V cubed. Okay, I'm going to skip over this one. Let's do both surface area and volume here. Okay, and both of those are listed right below the cone on the formula sheet. You got surface area, you got volume. Okay, you're going to have to find H here. Surface area should be pretty straightforward. L is my slant height. It's labeled on your formula sheet, so that way you know that L is the slanted side. 7 is obviously the radius of the circle. We should be able to just put that right in. Couple of things. First of all, rounding. Okay, it's 0.637, so that 63 is going to round up to 64, right? Got to watch our rounding. And then it's meters squared because it's area, surface area. Okay, everybody able to get that number? Yeah, everybody feel good about that one? That one's, I think, a little bit easier, okay, because it's just plugging it in. This one, we got to find the H, right? H and L are not the same thing. So on this one, I cannot plug in 11.4 because 11.4 is your L, it's not your H. So I drew a triangle down here. What are we going to have to do to find H of this? Pythagorean theorem, okay? A squared plus B squared equals C squared. Make sure you put the numbers into the right spots. The 11.4, the slanted height, is your C. It's your hypotenuse, right? So H squared plus 7 squared equals 11.4 squared. So we do 11.4 squared minus 7 squared. and it's 8.997, so I'm just going to go ahead and call that 9. If you want to leave that whole thing in your calculator, you can. It's 8.997, whatever. So you can take that whole thing. We're going to take this number, and we're going to plug it in for H up here. So we're going to go volume equals 1/3 times pi times 7 squared times 9. And you could just leave that in your calculator. Multiply it times 7 squared times pi times 1/3. Okay, these two, sometimes they may be close, sometimes they may not be. Okay, so don't necessarily look at the surface area and volume and say, oh, does it look right? Don't try to compare those two, because it'll be different for every problem. Sometimes they'll be really big, really far apart. Sometimes they'll be closer together. So don't necessarily look at those numbers as anything. Yeah.
I got 461.81.
Okay. Let's see here. Might have been because I used the 8.99. Let me try that. 9 times. Yeah. Okay, so you got 461.81. And that's why I left the 8.997 in my calculator. And so it doesn't seem like there'd be much difference, and really there's not. It's still 461. So I would probably be okay with either one, especially if you showed your work and say, I just went ahead and plugged in 9, because this was like 8.997. So go ahead and call them that 9 is not a big deal. If it doesn't come out to be like exactly 9 like that, you probably would just want to leave it in your calculator, just to get a little bit closer or more exact. But yeah, I would be okay with either one of these answers as long as you showed me what you're plugging in, okay? Any other questions on those two? Notice the label, cubed versus squared, okay? Surface area and volume, one's cubed, one's squared. Okay, let's do, let's see what we got. We've done a couple of these. We've got two three-dimensional figures sitting on top of each other, okay? The bottom is a triangular prism. The top is a triangular pyramid. Okay? And one of the things that I've tried to show you guys is, like, when I try to write these out, I like to write the formulas out and then just take the information and plug it in, okay? You can kind of do whatever makes more sense to you. But for instance, on this one, I would do big B times H. Big B is a triangle. Not only is it a triangle, but it's a right triangle. So we're going to do 9 times 12 divided by 2. And then the height of the bottom would be 10. Okay, now we're going to do the top. Okay, we have the same base. The base is still this triangle right here. Okay, it's the same base for both figures. So it's still 9 times 12 divided by 2. Here's where you got to be careful. Sometimes, some of the ones that we did had the same height on bottom as it did on top. Here what it's saying is 24 all the way from the bottom of the figure to the top of the figure. If this is 10 right here, what would be the height of the pyramid on top of the figure? How much? 14. Yep. So what we would need to do to find this height right here is we would have to take 24 minus 10. And so this would be 14. So 14 is going to go in here. Okay. So my question is, where do we ever use the 15? We don't. Okay. Sometimes there's maybe some extra information in there that the 15 doesn't even need to be used. Okay. In this case, we don't need the 15 for anything. The 15 is the hypotenuse of this triangle, and we don't need the hypotenuse to find the area of it. Okay. So keep that in mind, that sometimes they give you additional pieces that you may or may not need, or sometimes they don't give me maybe the height of this, but I have enough information to get to the height. Okay. So we're just trying to use what we've got to get where we need to be. Let's try plugging all this in. I kind of like to break it up into two separate parts. So 540 on the left, 252 on the right. Add those two together. 792. Volume would be feet cubed. Okay. Does that look right? Everybody? Questions on that one? Left here. Okay, this is the one we did yesterday. Spheres were the formula that we did yesterday, and there's two of them. The surface area of a sphere. This is pretty easy to recognize because it's a ball, right? Surface area is 4 pi r squared. Volume is 4/3 times pi times radius cubed. Okay, what's the first thing that I need to identify? Or really the only thing. The radius. That's the only thing that I need to know. Okay? So is 11 my radius? No. Because notice how the line goes all the way across here. Okay? If the line goes all the way across, then it's identifying the diameter. So what do we have to do to get from the diameter to the radius? Got to divide by 2. Okay? So really pay attention to what you're given. We use the same number. We just do different things with it. Okay. I think plugging that one in be pretty straightforward. If you want me to check that, I can, but just I got to make sure you have the radius. All right, here's the last one. Okay, try to do these two. I'm going to do it as you do it, and we'll see how we do. These are the ones that you have to set the proportion up on. Okay, I can't find the surface area and volume always based on what we have. Yep. Not always do we have all three dimensions. Here we happen to have all three dimensions. I'm going to put this up here. And check it if you need to. If you need some help with it, or if you need help with the calculator. What I would tell you about this is, on this one, yes, we do have all the dimensions of everything that we need. So you probably could find the surface area and volume using the formulas, but most of the time, I'm not given everything. So maybe I'm just given the height, or maybe I'm just given one of the sides of the triangle, okay? So does it matter which ratio I use when I set up my sides? No, it doesn't, okay? I can go 12 to 16, I can go 6 to 8, or I can go 8 to 12. We just have to set up the ones that are alike, okay? All of those would reduce to be 3/4, okay? And that's what we call our similarity ratio. For area, we got to square it. For volume, we got to cube it, okay? And then you set up your proportion. Okay, I don't have a review for today. That's why we kind of just did some problems in class.